Hi guys, welcome to this set of videos, and what we're going to cover here in this set of videos that follows along with the notes from your guys' textbook chapter 7 section 2 is we're going to begin to look at solving exponential equations. This is going to be where in the equation you're going to have a variable. Almost always that variable will be in the exponent position since we're solving exponential equations, and you'll be asked to solve for that variable. Now, what we did in the previous section, chapter 7, section 1, was we looked at graphing those exponential equations or functions, where again the variable is in the exponent position. But now, kind of keeping this theme of algebra, after we look at graphing the functions, then we take a look at what we can do to actually solve for the variable. So a couple of objectives or learning targets for you to kind of help us focus as we go through this set of notes. These are the things you should be able to do by the time we get done with this set of videos. You'll need to be able to solve exponential equations, and we'll start off by taking a look at what those look like and how you go about solving them. And then we'll kind of wrap things up here in this set of notes by solving exponential inequalities. The process is very, very similar. There's just a couple little extra things you've got to remember when solving an equation that has an inequality in it. Let's go ahead and jump right into these. Here's the way that these are going to work. Again, what you're going to be doing is we're going to be solving exponential equations. What that means is the variable is going to be in the exponent position. Let me show you a great example. If I were to give you 2 raised to the x power is equal to 8. Right? And what I'm asking you to do is solve this equation. Well, it definitely is an equation that you can solve. I have an equal sign. I've got 2 sides of the equation, and I have a variable, an unknown, something that I need to solve for. Now, this one's actually really very simple, and in many cases they will be. But really all you have to do is look at it and figure out what power do I need to raise this 2, right? What power does the 2 need to be raised to in order to get an 8? And of course, the answer is x is equal to 3, right? If I do 2 to the 3rd power, I'll get 8. So that's really kind of what we're going to be doing here in this set of notes to get us started with solving exponential equations. They do get a little bit trickier as we go, but for the most part, that's essentially what you're going to be doing. The variable will be the exponent, and that's what you're trying to solve for. Now, how do we go about doing that when it gets a little trickier? Well, here's how it's going to work. Okay, so what we've got here is as long as b, and remember from the previous section, b is going to be the base of our exponential function, right? So b is our base, and as long as b is a positive number other than 1, what we have is this fantastic property of equality. Here's what it means, and it should make perfect sense. I'll show you why in just a second. If I have b raised to the x power, and it's equal to b raised to the y power, here's what this is saying. What this is saying is I have the exact same base, right? b and b. But they're raised to the x and the y power. Well, the only way that these can be equal to each other is if the powers are also equal to each other. And that's exactly what it's saying here, if x is equal to y. Let me show you. I got a real simple example problem right here. We have 3 raised to the x is equal to 3 raised to the 5th power. Well, what is the only way, right? Well, I've got a 3 to the 5th over here. What is the only way that I can have, or that this equation, right, actually has a solution? Well, what you have to do is take a look at this and recognize the only way this works is if x, sorry, hold up, that's my highlighter. If x is equal to 5, which is exactly what this property is saying. As long as the bases are the same, and they are, then the exponents must also be equal to each other in order for the equality to be true, right? In order for the left-hand side to be equal to the right-hand side, the exponents will have to be equal if the bases are equal. And that's a really, really simple example and actually way too easy for Algebra 2. So here's what we're going to do to make things a little bit trickier. What we're going to do is, instead of giving you the same base on both sides, the bases are going to look a little different. And what you'll have to do is do some work to kind of get the bases to be the same. Then once the bases are the same, then we can set the exponents equal to each other, just like the property says, right? As long as I can get those bases to be the same, then I can set the exponents equal to each other. So here we go. I've got a slightly trickier one for you here, 2 and 8. But of course, we know that I can rewrite 8 as a 2 cubed. So let's do that. I have 2 to the x is equal. 8 is nothing more than a 2 to the third power, right? Because 2 to the third power is 8. I haven't done anything here. All I've done is rewritten it, right? It was an 8. I just rewrote that 8 as a 2 to the third. You don't have to worry about doing it to both sides. You only have to, properties of algebra say that if you add something to one side, you got to add it to the other side. If you multiply something by one side, you got to multiply it by the other side. But I didn't do that, right? All I've done is rewritten the 8. I've just changed the way it looks. It's still an 8. It just looks a little different. In fact, now it has the same base, which is exactly what I was going for. But be careful. Don't forget, it was already raised to the third power. Well, now I have a property of exponents, right? I have a 2 raised to the third, raised to the third power. This is a power of a power, which means we're going to multiply the exponents. So I'll have 2 to the x is equal to 2 to the 9th. All right, now you can see exactly how these problems are going to go. Your goal is going to be to get those bases to be the same by either changing one or both of them. You may need to change them both. And once you've gotten the bases to be the same, then we just apply the property, and just like that, we've got our answer. X is going to have to be equal to 9. All right, hopefully that makes a lot of sense. If it doesn't, you'll get the hang of it here on the next page. We'll do a couple more example problems, but we're just going to be using this property of equality for exponential equations. And again, your goal is to get the bases to be the same, and once the bases are the same, you can just set the exponents equal to each other. So head on over to the next page of the notes. We'll try a few more of these example problems, and I'll meet you guys there.